Dr. Zareb has come. Dr. Zareb, am I
Hi.
audible?
Hello. Good morning.
Hi. Good morning.
It's
Yeah,
good
it's
afternoon.
afternoon. Yeah.
Yeah, yeah.
Shall we start, sir?
Yes, sir.
Okay. So, participants, I'm giving a brief introduction about Dr. Zareb. Dr. Mehdi Zareb is a research scientist at Capgemini Engineering in Blagnac, France. He has 13 plus years of experience in research and development. He holds doctorate in automation from University d'Ivory, University Paris-Saclay. His expertise involves ecological transportation technology, resilient control systems, and IoT applications. He has contributed to many industrial projects, uh, including control system for drones that apply ADRC and PEMFC based hybrid propulsion systems for eVolts, IoT solution for smart homes, specifically air quality monitoring and UAV application in smart cities, traffic management and pollution tracking specifically. Additionally, uh, Additionally, he has been involved with innovative studies in AI-based diagnostics and automations. He has expertise with platforms like MATLAB, Python, Simulink. Dr. Zareb is very much active in ResearchGate and Scopus platforms also through his publications and research. And he's passionate about sustainability, advanced mobility, and smart city technologies. So we are very much lucky to have Dr. Zareb with us for the next 1.5 hours. And I hope that everyone will get lots of knowledge and a future path, I would say, because most of you are faculties. So uh, I request Dr. Zareb to start his talk. Thank you very much, sir.
Thank you for your introduction. First of all, good afternoon, everyone. Today we will explore the fascinating world, the Internet of Things and the industry. Especially in this presentation, we will see some examples. We can find it in the literature. The point here is to understand why Internet of Things is important in industry, and we will start first. We will start by the impact of the internet in the industry 4.0. Then for the what we said agricultural, what we know as smart farming, and then I will expose some example using IoT, Internet of Things, in the air quality monitorings. I will present two of my work and my students, and finally we will discuss about the challenges, the trend, and the challenges of this technology. Do you see my presentation?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Okay, good.
Invisible.
Okay. First of all, what is IoT? I know that everyone knows what is IoT. I know that, but in fact, this is a transformative technology that connect billions of devices. Till now, I think it exists about 30 or 29 billions of devices in the world. This billion of devices using the technology of IoT enable to collect, share, and analyze data in real time, which is very useful for the gathering of big data and then for the machine learning. So I know that's the IoT. You know that it consists of several layers, or we can see that these devices include sensors, machine, vehicle, and everyday object, creating a network smart system. That means if we introduce the IoT for the in the homes, so the system will change. He changed his name to smart homes. Same for factories. If the IoT introduce the factories, it will be known as smart factories. Same for the farming. Same for all the systems. So the application of the IoTs are several, starting by the application of it in the domain of agricultures. You can find in the literature a lot of work and papers that deal with the domain of the smart farming. For the smart farming, for the healthcare also is very important. Remote patient monitoring and smart media device and smart watches also. There is a lot of this application in real world is the most applicated in the in real cases, especially during the COVID-19 pandemic. The smart health is I can see by analyzing all the data and all the papers, that is this is the most significant application of the IoT. For the agriculture, as I said, for the smart farming system, for optimized crop management, for the smart cities. I didn't present it to manage the traffic management, energy efficiency system, etc. For the industry, and this is the subject of this presentation, to enhance automation and productivity through interconnecting devices, and this is the main application of the IoT. Now going to the next terms, which is industry, and here we found the industry 4.0. The industry 4.0, or also we can find the fourth, known as the fourth revolution. This nomination came by the end of 2012, the year 2012. It's integrate technology, advanced technology into manufacturing to create smart factories. It leverage IoT, artificial intelligence, robotics, big data, and cloud computing to enhance productivity, efficiency, and flexibility. And now we can found the second term, which is a smart factory. Here, this is the development of the industry during the next 2 centuries. So the key aspect of industry 4.0, the first one is interconnectivity. The second one is real-time data. Third is automation, as the third at the previous third industry. and customization. So in the first point, in the first key, we found we need an IoT, interconnectivity. So going to the next segment of this presentation. So Industry 4.0 and IoT. As I said, and we have seen, IoT transforms traditional factories into smart factories in Industry 4.0 by leveraging interconnected devices, sensor, and software. So there is a lot of layers. There is the sensors and the software. So the advantages of IoT in industry: enhance operational efficiency by enabling real-time data exchange. It reduces downtime and maintenance costs through predictive analytics. Optimizing resource utilization, lowering energy consumption and waste. Also improves product quality with automated monitoring and quality control. Strengthens supply chain management by providing real-time tracking and visibility. Boosts adaptability to changing market demand through flexibility manufacturing system. And also we can find a very interesting advantages, which is the increases of safety and compliance with advanced monitoring and alert systems. And all of these advantages lead to one big goal, which is the sustainable development. That means that's the real and the very important goal for IoT in industry is the sustainable development. Now going to the key application of IoT in the smart factories. The first one is predictive maintenance. The second one, energy efficiency. Third one is supply chain, the quality control and safety monitoring. The first points. So I will exert some examples for each one. For the predictive maintenance, is one of the most impactful IoT application in the smart factories. That means that it's largely demand. Second, because of the importance of maintenance in the industry. The IoT sensors monitor equipment for signs of wear and tears, allowing to predict failures and schedule repairs. This reduces downtime, which is very important, and extend the lifespan of machinery. So we can do this by the ability of the sensor to gather and communicate information about machinery and equipment. For example, including the temperature, vibration, and energy use, allowing for proactive maintenance to minimize downtime and provide productivity, as I said. So we can find the first example by Kashada, with they propose a scheme for maintenance. They name it maintenance 4.0, using intelligent and predictive system architecture, and the architecture integrates IoT machine learning and cloud computing for maintenance optimization. And by the way, it monitors and detects anomaly in equipment behavior. So the goal of this architecture is shift from fail and recover to predict and prevent maintenance practice. also it minimize, so it's not eliminate 100%, but it minimize downtime and enhance operational efficiency. So in the system architecture proposed by the first paper, we can see these architectures. So here they suggest a diagram. We can see that the point for the first there is four principal part in this architecture. The first one is the data collection to feed the database. Second part is offline data analysis. So it's an offline data. They propose this approach. It's offline data analysis. The second one is dynamic monitoring, visualization data, and triggering actions. And the last one, you can see here there is HMI interfaces. The last one, a decision support system, integrated augmented reality for execution. So we can find there. So we can find this is these architectures is very interesting. It's very interesting architecture. Sorry. So there is a lot of application if you want to see more further the real application in the literatures. But in fact, this is the main architecture that's it's combined the AI and the connectivity of the devices. Another example, this is an industrial example. This is the supervising and supervising the aircraft, the aircraft the defaults. This is a visual diagnosis. This company names Donecle, and this company, I worked for this company for 1 year with them. We worked with them to enhance the control systems, the control system of the UAVs. The point here is these UAVs are equipped with a camera, a high resolution camera, and the system is connected to internet by a software. And in fact, this company rent this system for the airlines company to help them to quickly make a diagnosis of the aircraft fuselage and then send the reports. So here the system works, is connected to internet and then to the cloud system of the company Donecle, and then the AI algorithms detects and then send back the reports. So I worked with this company. We can see that this is the online analysis is used for the airline companies, mean the civil companies, but for the military application, they deactivate the online option. Going to the second important application for the internet in the industry is for the energy efficiency. By using IoT technologies, smart factories can monitor and optimize energy consumption in real time, resulting in significant energy saving and cost reduction. And as I said, this is the most important goal for the application for IoT with the other goals. So there is a few way in which IoT can help improve energy efficiency in smart factories. The first one is the energy monitoring by using energy monitoring. So in this point, the IoT sensors can be used to monitor energy usage in real time across different area of the factory, for example. And this application is for the factories or for the smart is the same, or for the smart buildings. So I worked with some students in 2020 implementing a energy monitoring system in a smart home, and the principle is the same. So we put the IoT sensors or devices in different area of the factories, from production lines to lighting and heating system. So here the way that we put these devices, there is a lot of ways. So this is an optimal problem. So this is not our our issue here. This data can then be analyzed to identify area or inefficiency and opportunities for optimization. Here there is another. So this is the another part is that by using these sensors, it allows first to gather and log data from the different area of the factory, and then we can train with this big data an AI or machine learning system in order to identify the patterns, and then we applied the systems to be functional. The second way to improve energy efficiency is automated control system. So here the IoT devices can be used to automated energy usage across different systems in the factory. For example, lighting also and heating system can be automatically adjusted based on the occupancy levels for ambient temperature. So this is the second way. The first one is just the monitoring, and the second one is control. We can find also the renewable energy integration. So IoT technology can help smart factories integrate renewable energy sources such as solar or wind power in order to provide sustainable production process. Also, the process can help reduce reliance on fossil fuel and lower energy costs in terms of energy consumption management or of manufacturing process. So here, using the IoT allow us to integrate renewable energy efficiently. So the fourth way is the smart lighting, and this is this way is the larger one used, and we can see a lot of this application. Also, for the energy storage, IoT device can be used to manage energy storage system. This can include charging battery during off-peak hours when energy is cheaper, and using storage energy during peak hours when energy is more expensive. It's in in this application, in this way of application, we can see that it's the EMS, Energy Management System. That means that using the IoT can help us to manage to manage the storage of the energy. There is also the energy efficiency HVAC, where the devices can be used to monitor and optimize heating, ventilation, and air conditioning system. This can include adjustment the temperature based on occupancy or outside weather condition, or using sensor to detect when a space is unoccupied and reduce HVAC usage accordingly. That means that using the IoT devices can help us to know if there is some some area are more occupied than others, and then according to this we can turn off or turn on the heat, for example, air conditioning system. So this is the different way where the IoT is useful for in the factories. And as I said, the same thing it's applied for the smart building, for the smart home. It's the same. So I just show you here the minute. So this is the scheme proposed by the second paper of Canon, where they classify the different way energy aware awareness sensor networks. Now going to the next key points for the use of the IoT, the safety monitoring. The integration of the safety in industry is shown in the figure proposed by the paper of Ziliu. Here they propose paradigm of safety management in industry, and the IoT technology can enhance this safety safety monitoring in smart factories by providing real-time data. This is what's the connectivity, as we know as connectivity, and predictive analytic, enabling predictive maintain and alerting workers to potential hazards. So this is very important in industry, and now we can resume this the key concepts by determining determining and implementing safety policies deeply connected with the industrial developments. Sorry, just a moment. So we can resume the flowchart of this approach by so the information data came from the sensors, and then there is a procedure of data analysis, and then according to this analysis we define the risk assessment, and the workers are alerted. So it's alerted by using smartphones or any other way of alerting. Ziliu propose a three-stage of evolution. You can it was a very big scheme. I didn't want to present it here, but if you want, you can see the in the paper. So you can find that they classified they defined three stage of evolution: safety 1.0, safety 2.0, and safety 3.0. In the first stages, he defined the basic safety principle and practice. In the second one, integration of emerging technology for safety improvements. And for the third one, advanced safety strategy aligned with the Industry 4.0. As I said here, the real-time, the opportunity of this integration is allow the real-time risk assessment through IoT and AI. So also in all the application and all the key points, the AI and the IoT are gathered. It's enhanced decision making with data analysis. Going to the third points, which is the application of IoT in the smart farming. As the smart factories, as we can say, the agriculture 4.0. It combines IoT, wireless communication, sensors, and hardware for optimizing farming. So this is the second application. It enhances productivity through automation and data-driven decision making. So we can find that the smart farming technology gather unmanned aerial vehicles for monitor crop health and optimizing resource usage or other application. We can find also the IoT sensors. There is a lot of IoT sensors for the agriculture application. For track soil quality, for example, we can find the cheaper one and the most expensive one or sophisticated one. For the weather, we can find also the IoT sensors for the weather used for the agriculture. Also, we can find using the camera plant health in real time. Using there is a lot of application and using camera and the AI algorithm to detect the plant health. Also, the wireless communication. Use technology like LoRa, Zigbee, Wi-Fi for seamless data exchange. I had an application with some students in a smart farm, where the point was to detect the humidity and the temperature of the farm to allow the automatic system to better manage the water and electricity. And we have used a very cheap sensors and a very cheap microcontrollers. Now we can find the node MCU is very largely used. We can see in the next slide some application. The big data and AI also it's the a key technology for the smart farming. Now it's the progress of this of using big data and AI is very huge, more than the innovation in the sensors. Analyze usually the AI and big data are used to analyze patterns to predict trend and optimize process. In the just a moment. Here we can see the different layers in the smart farming, starting with the sensor layer, the network layer, and the service layer or the application, and then for the application layer. So this scheme is the same for all the application. The difference is just the type of technology or the type of the sensor. We can see, as I said, from the sensor for temperature, humidity, CO2, light, radiation, Moses, to the drones with the camera, and the different network layers technology used. Here you can see Wi-Fi, GPS for the 4G or 5G now, GPS for the unmanned air vehicles. I had a paper with a colleague. We published it in 2019, where we used UAVs in a smart to detect the and analyze the disease in uh, in a farm, and using GPS we record each picture taken by the UAV, and then we make a offline analysis, and then according to the analysis and the GPS location, robots can displace. I mean, UGV robots can displace uh, and react to the points. So this is the different technology as I present for the use for the in the smart farming. So as I said, the benefits. Just a minute. The benefits of using same for the farming is the increase the crop yield and reduce resource consumption, as the water, as all what we see. It's improve environmental sustainability. It's provide predictive maintain equipment to minimize downtime also. Now going to the fourth key application of IoT in the air quality monitoring. And here at this point, I have a lot. I have published some work. So in general, in these key points, we measure the pollutant and environmental parameters in real time. Example, city optimized traffic route using IoT data. The big benefits of using or implementing IoT in air quality monitoring. Not like the farming or the factories. It's the improved public health and data-driven policy. For this point, we need to clarify that there is several area to monitor the air quality monitoring. There is an indoor air quality monitoring, and there is the outdoor air quality monitoring. And for the indoor air quality monitoring, usually the most important pollutants are the particle matters with the different shape, from the dangerous one to another, and there is the CO1, monoxide of carbon. It's very dangerous, and other gases. This is the main pollutant that we deal with it. For example, there is a paper where we have implement air quality system in an indoor environment. And we have used in this system low-cost sensors for the monoxide of carbon and for the particle matter 10. And we have used what we know as Node MCU micro motherboards, and this is a very it's a very useful calculation. So here the point is to enhance the the quality of the measurement of the sensors by using intelligence by using fuzzy inference systems. So, for example, for each pollutant, we used two sensors, and then using the inference system, we enhance the accuracy of the measurements because we know that this kind of sensors are very inaccurate. So this is why we add the advantages of intelligent artificials such as the fuzzy inference system uh, to overcome this problem. And these devices are placed in a different area in the home. For example, here. And then there is a simple cloud system that is we have used the Google Cloud system to gather information and then collect the data to be analyzed and then to identify and estimate the pattern of this of each area of the chamber. The second application is in the outdoor monitoring. For the outdoor monitoring, here we have used a quadricopter equipped with a smart air quality monitoring system, electronic system. It has it has the 4G ability of connection, and by using the this UAV, we have applied in the University of Mustafa Stamboli Mascara in Algeria. So the application it was very simple. He has 2 points. This is usually the path where the students and the labor of the university take. This is the most path where the students take, and then this UAV can have can give real time data to the university website, and then it can also gives 3D information about the pollutant profile. So it helps to monitor well and better inform the university staff about the environmental pollution. And we publish the results of and the architecture and all the different approach in this paper. So now going to the fourth point in this in this presentation, which is the future, the challenges and the future trends. Starting by the challenges or the trend. Looking ahead, to the integration of AI and AOT will further enhance the decision maker in smart factories or in all the system that we apply the AOT. Also, we can speak about the 4G and the 6G, the application of this to better enhance the quality of the connection and the connectivity. Edge computing will reduce latency by processing data closer to its source, while energy efficient IoT devices will minimize cost and environmental impact. So this is the future research and the future development. So it will go where this to this to this area. It's AI or machine learning application. And the going to the challenges. While the benefits of the IoT in smart factories or in industry are substantial, sorry, challenges remain. The first one is the cost of the implementation, and the need of skilled person are significant barriers. So I speak about the large use of IoT in industry. Till now, I can see the solution. Till now, we can say that the application is not too large because of these issues, the cost and the need of skilled persons. And there is another challenges or problem. It's about the cybersecurity. It's a big concern because first of all, for the number of the connected devices, as the interconnection system are vulnerable to attack. However, there is however, these challenges can be addressed with the phased implementation, investment in training, and robust security protocols. So this is a very big challenge. Is this the cybersecurity? Going to the solution. The first one we can we can resume it or summarize it to start small. The companies can start by implementing industry technology on a small scale. First of all, to gain experiences, and then, by the way, build expertise before scaling up. As we have seen, the IoT in industry is based on the IoT devices and the big data that came from each area. So starting small, it can help to scaling up the Internet of Things in industry. Also, the investing in work phase training is very important, and the implementing of robust data privacy measurement can also mitigate risk for the issue of data security. So we can see that in overall the future research can focuses on developing more energy efficient IoT devices and leveraging AI to drive innovative in production processes, and making them, by the way, more intelligent and autonomous. So this is the future research focuses on this subject. To conclude, IoT is at the heart of smart factories and smart industry, driving efficiency, productivity, and sustainability. It transforms traditional process into interconnected system that adapt to market demands. As we address the challenges and explore new opportunities, IoT will refine the future of manufacturing. And thank you. Thank you for your attention. I now open the floor for the question.
Oh,
Thank you very much, sir. It was a
thank you,
very
sir.
nice session. There are some questions on the chat box, sir. If you can open that.
Yes.
Please turn on your camera, sir.
What is FUSI concept is best suitable in air quality monitoring? It is a very good question. In fact, I can address you to see my paper. You have my contact. If you have a problem to upload it, I can send you back a copy. Yes, as we can see that it's the best one. We can say that it's effective, suitable is effective for air quality. First of all, the first challenge, for example, that we have in our application, we want to apply the intelligence system in a small chip, which is a node MCU. So we know that it has a limitation regarding the computation, and so for that, we have found that FUSI is the best way. But in fact, if we take the IoT concept in general, we can apply online approaches. If we have a high quality of internet, for example, as 6G or 5G, we can apply as I show you the example of Donecle. So they have a camera, and then they use the information, the data came from the internet to feed back their application. And for air quality, yes, we can say that the air FUSI, it's effective way. Using also the neural network is very effective. I didn't really use it in real, but in fact, in terms of training the patterns or identification of the patterns, the neural network is way better than the FUSI concept. Thank you for your remark, TV.
Any other? There is another one question. Share some
Yes.
more practical implementation experiences.
Yes. Yes, there is. I didn't make a lot of here in the presentation. Yeah, a lot of experience, practical implementations. But I can share with you an application in the maintenance. There is a fact. Yeah, the maintenance. There is a CNC CNC device where they implement a camera. Yes, they implement the camera, and then they feed back neural networks. In fact, to see if the object is what he's really doing what he's do. For example, if the CNC is cutting some parts. So let's say that he want to cut a letter A, and then we're using the connected device, which is the camera, and the neural networks. They detect the current letters, and then the CNC do his work. If there is a failure, in a way, so they can stop the automatically the CNC, and then they prevent that it's not For example, there is a metal plate, so they prevent the failure, the catastrophe, or the lose of the, and the important thing is this system can quickly detect the issue, so it don't need a lot of time to detect this. This is for the CNC. In general, yes. And there is also an application for the risks, for example, using a lot of network of sensors. We can prevent, for example, from the gases, prevents the labor from some problem in, for example, as the pollution, for example, gases, toxic gases, or any kind of, and then they send back the information and the alert to the smartphone. This is what I have found. Yes. There is another question.
Legal hurdles are increasing as the number of IoT devices is increasing. How can we minimize it?
Yes, an increase as the number of IoT devices increase, and how can we minimize it? In fact, it's a good information. So I think to minimize the thanks. Yes. In fact, I didn't see this. It's a very important question. So it's by using new AI approaches. I think we can handle some of this problem, this kind of legal handles, and also we can use some. We cannot minimize it at all, but we can let's say reduce it. Yes, because minimize it has the sense of optimizing. You see, this is the goal. First of all, we need to fix it a goal, and effective goal, said what we want to do, and then we can apply an approach, to not minimize it at all, but a little bit monitor it. You see.
Any another question? Any
Sir,
participants?
I have one small question, sir.
Yes.
Sir, regarding this air quality, can you suggest us some available database which we can use for the test?
Okay.
And is it a problem which is having it's a big data problem or small data problem? What kind of database is available for this particular problem?
Okay. So you mean the application of air quality monitoring that I present? Yes.
Yeah, yes.
If in fact for the database, so you can if you let's see, if you want to have an idea about the pollution in some part of the world. For example, if you are interested in the for example, in your own city, or there is a website. It's I think its name is Air Now, something like that.
Oh, no. Okay.
And then I think there is a lot of yeah, I know that the when I try to use some from some data, I think the American agency, they have some interesting database, but it's not an online in the day in the
To purchase.
yes. But in fact, if you want to take some information to train your AI machine learning, you can find a lot of and I think it's free to you, it's free to use. and it depends also what kind of pollutant you want. Because you know that the pollution is not it's so the data that you gather that are gathered are not very accurate because they based on networks, and it depends about the placement of each device in the city, for
Sensors.
example. And as I present the solution of using UAV, it complete the information, since it gives you a 3D information, because you know that's the sensor. It takes just the steady state of the value of the pollutant. But in fact, in general, to respond to your the first part, there is the websites they provide data. In general, they are interested in some kind of uh, of pollutants, just some. They don't
Specific.
make yes. So this is the very important. If the weather data you can find a lot of website for this. And what is the second part of the question was?
What kind of database? I mean, is it a big database base or a
Yeah,
small database? I mean,
yeah,
that will
yeah.
help us deciding the kind of AI technique to be used.
Yes. In fact, if you get to the for the value, it's a small data, but in fact, if we take there isn't if you mean the big data, the
Mhm.
during the time, that mean for 1 year, for 2 years, you can find a lot of data. You have to be careful about I think they provide each 1 hour they take measurements each 1 hour, if I remember. So it's a huge kind of data. If you take, for example, 1 year, it's just the values. I think it's a good information. So you can do something if you have if some research to do, or it can be useful. And we can trust this kind of since it came from .org website. You can trust this data. And the best way is to collect your own data. If you have some subject, or if you're it's the best way, because you can understand and you can choose the for example, the timing. That's
Timing, location, frequency,
yeah,
everything.
yeah. Yes,
Okay.
there is another question.
Any question? Participants have any question? They may ask via chat box, or they can raise their hand so we can unmute them.
Uh, for the presentation, you mean?
Sorry,
No, sir. We are asking the participant to if they want to
participants.
ask.
We are asking
Okay, okay.
participants for questions. Any questions? Hello,
I think no more question now.
all are present. Hello.
Okay, sir. I think there is no
Okay.
question anymore.
Sir, one group photo, sir, with you. Please,
Okay.
please, participants, turn on your camera so we can take group photo with our foreign expert. Please smile.
Okay.
Okay. Thank you.
Thank you.